The Endless Expanse of the Pacific Ocean, 1944. The sky is dark, heavy with smoke, and filled with the terrifying roar of radial engines. A young Japanese pilot sits in the cockpit of a Mitsubishi Zero, his knuckles white on the flight stick. He is not flying to survive. He is flying to die. Fueled by fanatical loyalty, he is part of the infamous Kamikaze, the divine wind. His mission is painfully simple: guide his bomb-laden aircraft directly into the wooden flight deck of an American aircraft carrier. Beneath him, the Allied fleet looks like a collection of desperate steel islands. Thousands of sailors stare up at the sky, watching a nightmare unfold. The ship's anti-aircraft guns unleash a wall of fiery lead. Flak fills the air with black puffs of smoke. Hundreds of rounds are pumped into the sky every single minute. But the Kamikaze does not care about evasive maneuvers. He does not flinch. He accelerates directly through the stream of bullets. Bullets tear through his wings, but it is not enough. The plane slams into the carrier's superstructure in a blinding explosion of aviation fuel and tearing metal. Scores of young sailors perish in seconds in the early years of the Pacific War. This was the brutal reality facing the United States Navy. Traditional anti-aircraft artillery was failing. Shooting down a fast-moving, suicidal enemy plane was like trying to hit a speeding rifle bullet with another bullet. The math was horrifyingly stacked against the defenders. Before 1943, it took an average of 20,000 anti-aircraft rounds to bring down a single enemy aircraft. Gunners had only two options for their explosive artillery shells: contact fuses, which required a literal direct hit on the plane, or timed fuses, which had to be manually set by hand before firing to explode at a specific distance. If a gunner miscalculated the enemy's speed or altitude by even a fraction of a second, the shell would explode harmlessly in empty air, miles away from the target, or streak past the aircraft without detonating at all. Against standard bombers, this low accuracy rate was dangerous. But against kamikaze pilots, who treated their own bodies as precision-guided missiles, it was downright catastrophic. The Navy needed a miracle. They needed a weapon that could think for itself. They needed a shell that didn't need to hit the target, but merely get close enough to tear it out of the sky. Far away from the smoking wreckage of the Pacific, a group of radical scientists was working on what would become the second most closely guarded secret of world war Teucer, passed only by the Manhattan Project. They called it Section T, led by a brilliant physicist named Merle Tuve and backed by the Vannevar Bush's National Defense Research Committee. This elite team was given an impossible task: invent a miniature radar set, shrink it down to the size of a teacup, stuff it into the nose of an artillery shell, and make sure it survives being blasted out of a cannon to understand why military experts deemed this impossible. You have to look at the violent physics of heavy artillery. When a 5-inch naval gun fires, the shell inside experiences an acceleration force greater than 20,000 times the force of gravity. It is spun at more than 30,000 revolutions per minute to stay stable in flight. In the 1940s, electronics meant fragile glass vacuum tubes, delicate filaments, and bulky batteries. If you put a standard radio circuit inside a cannon shell and pulled the trigger, the explosive blast would instantly pulverize the glass. tubes into fine dust before the shell even left the barrel. Yet Section T refused to accept defeat. They began testing ruggedized glass microtubes, surrounding them with shock-absorbing silicone wax, liquid blocks, and specialized plastic resins. They redesigned every tiny capacitor and wire to endure crushing mechanical shocks. The concept was mind-boggling as the shell hurtled through the air at 2,000 feet per second. A microtransmitter inside would broadcast a continuous radio wave signal. As the shell approached, a metallic object, like the wing of a Japanese Mitsubishi Zero or a Nakajima bomber, the radio waves would bounce off the aircraft and reflect back to the shell. The interaction between the outgoing and incoming signal created a wave pattern inside the circuit. When the shell reached the lethal zone roughly 70 feet from the target, the strength of the signal would trip a tiny thyrotron tube, acting as an electronic switch. The switch discharged a capacitor, igniting the detonator and triggering a violent explosion. The target aircraft would be instantly shredded by a massive cloud of razor-sharp shrapnel. Even without a direct collision, this was the world's first operational smart weapon, the Radio Proximity Fuze, officially designated by the military under the deceptive code name Variable Time or VT Fuze to confuse enemy spies. But turning a scientific breakthrough into a weapon of mass production was a colossal nightmare. Millions of these microscopic electronic marvels were needed. American industry responded with unprecedented coordination. Over 80 different factories, thousands of assembly line workers, mostly women with meticulous assembly skills, and dozens of scientific institutions worked around the clock under extreme military security. Every worker knew they were building something critical, but almost none of them knew the full picture of what the device actually did. By late 1942, the top-secret crates were loaded onto war transports and shipped across the globe, bound for the blood-soaked waters of the Pacific Theater. The era of manual anti-aircraft gunnery was about to end, and the Japanese Navy was completely unaware of the technological thunderbolt heading their way. January 5, 1943, near the Solomon Islands in the South Pacific, the light cruiser USS Helena was patrolling dark, enemy-infested waters when a group of Japanese Aichi D-3A dive bombers suddenly appeared out of the clouds, diving straight toward the task force. On board the Helena gun crews rushed to their battle stations. The 5-inch gun turrets swung violently toward the sky, but this time, locked inside the ammo hoists, were the brand-new top-secret VT Proximity Fused shells. The order was given to open fire. Thunder shook the deck as the heavy naval guns began to bark. 5 rounds soared into the sky toward the leading Japanese bomber in the past. Those 5 rounds would have missed or sailed harmlessly past. But as the third shell streaked within 60 feet of the bomber's fuselage, its internal radio transmitter picked up the echo of the enemy plane. Instantly, the electronic switch fired. A brilliant orange fireball erupted in midair right beside the bomber, showering its fuselage and engine with hundreds of high-velocity steel fragments. The plane's wing snapped, smoke poured from its engine, and it plunged straight into the Pacific, down with just 5 shots. The officers on the bridge of the USS Helena stood in absolute shock. They had just witnessed a fundamental shift in the history of naval warfare. As the Pacific War dragged on into 1944 and 1945, Imperial Japan realized it could not win a conventional industrial war against the United States. In absolute desperation, the Japanese High Command unleashed their ultimate weapon, organized, massed kamikaze suicide strikes. Thousands of young fanatic pilots were ordered to crash their explosive-packed planes directly into American battleships, cruisers, and aircraft carriers. During the Battle of the Philippine Sea and later the massive invasion of Okinawa, the skies literally turned black with swarms of kamikaze aircraft. They came from all angles, diving out of the blazing sun, skimming mere feet above the ocean waves, and weaving through heavy traditional flak against standard anti-aircraft weapons. These tactics caused terrible casualties. But the United States Navy was now armed with the Proximity Fuze, combined with advanced radar tracking and automated gun directors. The American fleet had created an invisible, impenetrable shield of exploding steel. When a wave of dozens of kamikazes dived toward an American fleet, the air roared with heavy 5-inch artillery fire. The proximity fuses transformed every single artillery shell into an automated killer. Gunners no longer needed to hit the kamikazes. They just needed to fire into the general flight path. Shell after shell exploded with mathematical precision right beside the incoming suicide planes, blowing off their wings, destroying their control surfaces, and detonating their onboard bombs long before they could reach the pieces to carry American ships. The statistical jump in lethality was staggering. Historical data revealed that the proximity fuse increased the effectiveness of American anti-aircraft guns by an unbelievable 700%. What previously took thousands of rounds to achieve was now accomplished in a fraction of the time with a handful of shells. During the Battle of Okinawa, the largest and bloodiest naval air battle of the Pacific War, the Proximity Fuze saved dozens of American aircraft carriers and troop transports from complete destruction, preserving tens of thousands of Allied lives. Japanese commanders were left completely baffled. They could not comprehend how American ships were knocking their fast-moving suicide aircraft out of the sky with such horrifying consistency. Even in total darkness or dense fog, the secret was kept so tightly guarded that American commanders strictly forbade the use of proximity fuses over land for most of the war. The Pentagon lived in mortal terror that an unexploded VT shell might fall into enemy hands, allowing German or Japanese engineers to reverse engineer the miniature radio tech. It was only during the crisis of the Battle of the Bulge in late 1944 that General George S. Patton was finally allowed to use proximity-fused artillery shells against Nazi infantry on land. The result was devastating airburst explosions that destroyed enemy positions hiding in deep trenches, fundamentally changing land warfare forever. When historians look back at the decisive technologies that won World War II, the conversation usually centers on the atomic bomb and long-range radar. But top military brass, including Nobel laureates and legendary naval admirals, placed the proximity fuse right alongside them. Admiral William Bulge explicitly stated that the VT fuse was one of the key factors that allowed the U.S. Navy to push across the Pacific without taking unbearable fleet-destroying losses. The proximity fuse was far more than just a clever piece of artillery hardware. It was a triumph of human genius, industrial sheer willpower, and microscopic engineering. It proved that in the crucible of modern conflict, scientific innovation could triumph over blind fanaticism. By packing an entire radar station into a 5-pound shell capable of surviving the violent fury of a cannon blast, American scientists didn't just build a better trigger, they birthed the age of modern, smart munitions and sealed the fate of the Imperial Japanese Navy once and for all.